Okay, in this video we're going to be looking at second derivatives. This is not a big one at all, really. Second derivatives is just doing the derivative twice, okay? It just adds some complexity from time to time. Okay, so if you're looking at this first one here, I think maybe before we do that we should look at the notation. So we know that if we have an original function as f of x, the double derivative is f dash dash x, okay? If the original function is y, the double derivative is y dash dash, okay? Or another way to write it is d squared y by dx squared. It's kind of like diffing, so we know that the original is dy by dx, and it's kind of like doing it twice, okay? So in this first question it says find f dash dash x, so that's a double derivative for that. So I hope you guys can see that the first thing to do is a chain, okay? So you do the outside, so it's 4 comes down the bottom, and then 3 up the top, and then we times by the chain here. So the derivative of minus 5x squared will be minus 10x. Hopefully we're getting better at those. I guess we could tidy that up. So do the number and the two numbers. We've got negative 40x times by 1 take 5x squared or cubed. All right, so that's f dash x. So to do f dash dash x, you hope you guys can spot, that's the difference here. It's actually going to be a product rule. So first function we'll say is the minus 40x. So u dash would just be negative 40. V is our second one, which is very similar to our original. So v dash is going to be a chain. Put the 3 out the front. Subtract 1 to 3. And then times by the derivative of the chain. So the derivative of minus 5x squared is minus 10x. Okay. So to work out f dash dash x, okay, remember it's u dash b plus uv dash. So the derivative of u is 40x, minus 40x, minus 40. And then we're going to multiply that by the original v, which in this case is just 1 take 5x all squared cubed. Put a plus between them, and the original u is just minus 40x, so I might just put that in the bracket for now. And then we're going to times it by v dash. So I might tidy the 3 and the negative 10 together, so that's really negative 30x times by 1 take 5x squared all squared. Okay, so yeah, we've got some negatives and negatives, so we've got to be careful. For now, that's okay. Just realise if you go to Hazy and things, they'll probably tidy them up. But if you're just finding f dash dash x, that's good enough. Okay, just Hazy has these, so we've just got one like here. It just says, look, show that the double derivative plus the original y is 0. So let's work out first off what dy by dx is. So dy by dx, so the derivative of sin is cos, keep the constant out the front, so it's got to be 2 cos x. The derivative of cos of x, so keep the 3 at the front, is going to be minus sine of x. All right. Now, the second derivative, so just notice the notation, d squared y by dx squared. Okay, so keep the constant at the front. The derivative of cos is minus sine of x. There's no chains in these. That's actually take 3 out the front, isn't it? Derivative of sine is just going to be cos of x. So all I've done is just taken the negative out the front to be negative 3, and then just diffed sine of x to be cos of x. All right, so let's have a look. So what we've got there is really negative 2 sine of x. Take 3 cos of x. Now it says is if you add y, so we know that y is this, so this is like a substitution, so we just put that down here. So y is actually 2 sine x plus 3 cos x. Don't need anything else out the front. Guess what that equals? We can see that negative 2 sine x cancel, the negative 3 cos x cancel, and it does equal 0. Okay, so we've just shown that. All right, so double derivative is, it is really important, but it is really just diffing and diffing again. So just spot products and quotients and all that sort of stuff. And just sometimes you'll have to substitute to prove something. Okay, there's an exercise here to work on, so you can just start that and finish that when you can. Thanks.